Good day! Welcome to our online math tutorial, series of math lessons for grade 10. Tara, sabay-sabay tayong matuto at home. This is grade 10 mathematics for quarter 1, module 5, geometric sequences versus arithmetic sequences. This is teacher Marian M. Guerrero, your math teacher for today. Before we start, please prepare the following: your math module, piece of paper, a pen, and your notebook. In this lesson, you are expected to determine a geometric sequence, identify the common ratio of a geometric sequence, find the next term of a geometric sequence, and differentiate arithmetic sequence and a geometric sequence. Let us start our lesson with an activity. Am I arithmetic or not? So you have to identify whether the given sequence is arithmetic or not. Write AS if it is an arithmetic sequence, otherwise write NA. Remember, last week we have discussed all about arithmetic sequence, and we have figured out on how to determine if a sequence is arithmetic or not. Number 1, 5, 11, 17, 23. To determine if it is an arithmetic sequence, we have to get its common difference. So in finding the common difference, we are to subtract a term to its preceding term. For example, common difference is 11 minus 5 is 6. Another, 17 minus 11 is also equal to 6. The two common differences are equal, therefore this is an arithmetic sequence. For number 2, 3, 9, 27, 81. Let us try to get a common difference. Subtract the second term to its first term, 9 minus 3 is 6. And when we subtract the third term to its second term, 27 minus 9 is 18. Notice that the differences of the two are not equal. Therefore, this is not an arithmetic sequence. Number 3, 3, 6, 9, 12. Let us determine the common difference by subtracting the second term to its first term. 6 minus 3 is 3. And also, subtract the third term to its second term. 9 minus 6 is also equal to 3. There is a common difference of 3. Therefore, this is an arithmetic sequence. Number 4. 5, 10, 20, 40. Subtract the second term to its first term. That is 5. And subtract the third term to its second term. 20 minus 10 is 10. Notice that the differences are not equal. Therefore, this is not an arithmetic sequence. Number 5, 125, 25, 5. Notice that when we subtract the two terms, 25 minus 125 is negative 100, and 5 minus 25 is negative 20. They are not equal, therefore, this is not an arithmetic sequence. Notice that only number 1 and number 3 are arithmetic sequence. What kind of sequence are the others? For number 2, number 4, and number 5. What kind of sequences are these? For us to know more about geometric sequence, let us consider the problem below. Christmas season is approaching. Anna is planning to buy a new blouse which costs 300 pesos as a gift to her mother. She started saving money on the first week of November and doubled the amount to be saved every week. If she started saving 5 pesos on the first week, will she be able to buy the blouse at the end of the second week of December? In this problem, let us have this table. For the first row, the number of weeks starting from the week 1 of November up to the second week of December. And for the second row, we have the weekly savings of Anna. For the first week, Anna saved 5 pesos. And for the next week, it will be double the amount. Thus, Anna's saving is 5 pesos times 2, that is 10 pesos. For the third week of November, doubling the amount of the last week, 10 pesos times 2, that is 20 pesos. And for the fourth week, 20 pesos times 2 is 40 pesos. Next, for the first week of December, doubling the amount from the last week, 40 times 2 is 80 pesos. And for the last week, the second week of December, that is 80 pesos times 2, that is 160 pesos. Given all the savings of Anna from week 1 of November to the second week of December, the total savings now is 315 pesos. So the amount obtained of 315 pesos, therefore, Anna will be able to buy the blouse at the end of second week of December. Notice that the sequence formed here in the weekly savings of Anna, 5, 10, 20, 40, 80, 160, this is an example of a geometric sequence. And what is a geometric sequence? A geometric sequence, it is also known as geometric progression. It is a set of terms in which each term after the first is obtained by multiplying the preceding term by the same fixed number called the common ratio, which is commonly represented by R. Given the sequence earlier, the savings of Anna, 5, 10, 20, 40, 80, 160, notice that each term in the sequence is obtained by multiplying a constant term, and that number is 2, which is doubling the amount of her savings in each week. 5 times 2 is 10, 10 times 2 is 20, 20 times 2 is 40, 40 times 2 is 80, and 80 times 2 is 160. This fixed number 2 is what we call the common ratio. And we can obtain the common ratio by dividing a term to its preceding term. For example, 10 divided by 5 is 2, 20 divided by 10 is 2, 40 divided by 20 is 2. That is the same as for the others. 80 divided by 40 is 2, and also 160 divided by 80 is 2. There is a common ratio of 2. Therefore, it is a geometric sequence. Let us now have some example. Find the common ratio and the next term of the sequence 3, 12, 48. For this, we have to find or identify the common ratio. We can identify the common ratio by dividing the second term to its first term. And that is 12 divided by 3, which is equal to 4. From this, multiply the common ratio to the preceding term to get the next term. Since we are given the common ratio is 4, and the last term given is 48, let us multiply 48 times 4 will give us 192. Therefore, the next term in the sequence is 192. Another example, find the common ratio and the next three terms of the sequence 2, 6, 18, 54. First, identify the common ratio. We can identify it by dividing the second term to its first term. 6 divided by 2 is equal to 3. Thus, the common ratio is 3. We will use this to multiply to the preceding term to get the next term. To get the fifth term, that is 54 times 3, which is 162. Sixth term, 162 times 3 is 486. And for the seventh term, 486 times 3 is 1,458. Therefore, the next three terms of the sequence are 162, 486, and 1,458. For our next example, find the common ratio and the next two terms of the sequence, 400, 200, 100. Notice that in this sequence, it is descending in order. Thus, when we identify the common ratio, we have to divide the second term to its first term. 200 divided by 400, that is, when we simplify, we will come up with 1/2. Thus, the common ratio is 1/2. Then, multiply the common ratio to the preceding term to get the next term. Therefore, a sub 4 is equal to 100 times 1/2, that is 50. And the a sub 5 is equal to 50 times 1/2, that is 25. Meaning, the next two terms in the sequence are 50 and 25. Based on our lessons from the last week, we can now compare and differentiate an arithmetic sequence and a geometric sequence. For arithmetic sequence, we are adding a constant term. For geometric sequence, we are multiplying a constant term. Also, arithmetic sequence has a common difference, while a geometric sequence has a common ratio. And in getting the next term of an arithmetic sequence, we are subtracting a term to its preceding term. While for the geometric sequence, we are dividing the second term to its first term. Let us now have some examples. Determine whether the sequence is arithmetic or geometric. 12, 15, 18, 21. We have to check if there is a common difference or a common ratio exists. For the common difference, we will subtract the second term to the first term. That is 15 minus 12, which is 3. Also, let us also subtract the third term to its second term. 18 minus 15 is also equal to 3. Notice that there is a common difference of 3. Now, let us check if there is a common ratio. To get the common ratio, we will divide the second term to its first term. And that is 15 divided by 12. When we simplify this, that is 5 over 4. And also, dividing the third term to the second term, 18 all over 15, which is 6 all over 5. Since 5/4 is not equal to 6/5, then there is no common ratio. It means the sequence is an arithmetic sequence. For the last example, determine whether the sequence is arithmetic or geometric. 12, 5, 15, 45. Check if a common difference or a common ratio exists. For the common difference, subtract the second term to the first term. 15 minus 5 is 10. And then subtract also the third term to the second term. 45 minus 15 is 30. Notice that the two differences are not equal. Therefore, there is no common difference. For the common ratio, divide the second term to the first term. 15 divided by 5 is 3. Also, divide the third term to the second term. 45 divided by 15 is also equal to 3. Since the two ratio are equal, then there is a common ratio of 3. Meaning, the sequence is a geometric sequence. Given the examples that we've had in our lesson, let us now synthesize our discussion. First, a geometric sequence is a set of terms in which each term after the first is obtained by multiplying the preceding term by the same fixed number called the common ratio. A common ratio is obtained by dividing a term to its preceding term. And the terms in arithmetic sequence is obtained by adding a common difference to its preceding term, while the terms in a geometric sequence is obtained by multiplying a common ratio to its preceding term. With that, that is all for today. Thank you for listening.